a terrific question, and no, it's very relevant these days because the LHC had a successful run. We all know it ran not at the designed energy because there was a small mishap at the beginning, and they had to be careful. It was a great success because the Higgs particle was found. But we're now all readying for the next run, which actually will start at the beginning of June of this year. And it will run at much higher energy, we hope around 14 TeV. And so now the real work begins, because I think, we were all very, very happy that the Higgs particle was found, but it was, in some sense, predicted 50 years ago. And it was long in the making. And I think we would all be seriously surprised if the Higgs particle would not have been found. But of course, now the question really is what's next? And it's important to stress that we have this beautiful standard model, including the Higgs particle, but the standard model is internally inconsistent. It will not survive. If the standard model, as we know it right now, will make the whole universe unstable and the universe will collapse, and clearly doesn't. It has been around for 14 billion years. So somehow the universe knows something that we do not know. And if our old kind of gut feeling is right, then we are strongly believing that part of the answer should be found in the next run. So what will happen is now that we'll have the LHC working at much higher intensity and energy. And one of my colleagues described it yesterday as follows. We have a race which starts with a sprint, a 6-month sprint, starting in June, so the second half of 2015, where we will very, very rapidly cover everything we have done before, then double the number of data. And if there's anything out there, like a new particle or a new force, something like we are hoping for, like supersymmetry, if it's out there, it should we should see some of it in. So new particles should kind of announce themselves in the next half year. And after that, the race turns, as my colleague said, into a marathon. Then we'll have another 2 or 3 years where we have to collect a lot of data. And we will be looking for other kind of phenomena that are statistically less likely to appear. We only looked at, in some sense, a small part of the standard model. We only looked at some of the simple processes which have a high probability of appearing. And but there are many other opportunities there. And the only way to find them out is to wait for a long time. And so that's something that we will start doing now, and we'll be kind of mapping that out. So it means that you will also brace ourselves for a period where there will be many false alarms. That's the statistical nature of quantum mechanics. So we know even if there's something new out there, it will manifest itself only in a statistical fashion. So you have to gather a lot of data. There will be indications of particles which then will disappear. But we get an exciting 6-month, second half of 2015. And then we'll have to probably stick around for a longer few years to get the next round of measurements. Another question actually related to this is